Good morning, everyone, and welcome to chemistry class. Today, we are going to discuss the properties of colloidal solutions. Now, let's discuss the physical properties of colloids. Colloids are heterogeneous in nature. They consist of two phases, the dispersed phase and the dispersion medium. The colloidal solutions are quite stable. Their particles are in a state of motion and do not settle down at the bottom of the container. Colloidal particles are easily passed through the filter paper. So, ordinary filter paper cannot be used for removing the dispersed phase because the size of the pores of filter paper is bigger than the size of the colloidal particles, which can be easily passed through the pores of the ordinary filter paper. Therefore, animal membrane can be used to separate the colloidal particles from the crystalloids. Because animal membrane does not allow the colloidal particle to pass through it. And the colloidal particles are not visible with the naked eyes. And the color of colloidal solution depends upon the wavelength of light scattered by the colloidal particles, which in turn depends upon the size and the nature of the particle. For example, in a gold sol, if the particles are very fine, the color is red. But with growing size of the particles, the color changes to purple, then blue, and finally golden. The color also depends upon the manner in which the light is observed. For example, for the light focused on the mixture of milk and water, if reflected light is viewed, it is blue. But if transmitted light is viewed, then it is red. And the particle size of colloids lies between 1 nanometer to 1000 nanometer. Now let's discuss the optical properties of colloidal solution. That is Tyndall effect. If a strong beam of light is passed through the colloidal solution placed in a dark room, the path of beam gets illuminated with a bluish light when viewed at right angle to the direction of the passage of light. The path of light becomes visible to the scattering of light by the colloidal particles. And this phenomenon was observed by Tyndall in 1869 and it is called Tyndall effect. So, Tyndall effect may be defined as the scattering of light by colloidal particles present in a colloidal sol, and the illuminated path of beam is called Tyndall cone. And Tyndall effect is observed only when it satisfied the two conditions. That is, the diameter of the dispersed particle is not much smaller as compared to the wavelength of light used. And there is a large difference in the refractive index of dispersed phase and the dispersion medium. Now let us discuss the Brownian movement, that is a mechanical property of colloidal solution. Robert Brown in 1827 observed the continuous zigzag motion of pollen grains suspended in water, and it is called as Brownian movement. Brownian movement may be defined as continuous zigzag movement of colloidal particles in a colloidal sol, and it is due to the unequal bombardment on colloidal particles by molecules of dispersion medium. And with the increase in the size of colloidal particle, chance of unequal bombardment decreases. Hence, Brownian movement decrease. And Brownian movement opposes the force of gravity and does not allow the colloidal particles to settle down, and therefore it is responsible for the stability of colloidal solution. It has also helped in the determination of Avogadro's number. Now let's move to the electrical properties of colloidal solution. And the most important property of colloidal solution is that the colloidal particles always carry an electric charge. The colloidal sol is stable due to the presence of same charge on dispersed phase particles, which may be either positive or negative, while the dispersion medium has an equal and opposite charge. For example, arsenic sulfide particles are negatively charged, whereas the dispersion medium water is positively charged. Similarly, ferric hydroxide particles are positively charged, whereas dispersion medium water is negatively charged. Now let's learn some examples of positively charged and negatively charged colloidal salts. Hydrated metal oxides like alumina Al2O3.XH2O form positively charged salts, whereas metal particles form negatively charged salt. Basic dye stuffs, for example methylene blue, it is an example of positively charged salt, whereas metallic sulfides are the examples of negatively charged salts. Hemoglobin and oxides like TiO2 salt, they are the examples of positively salts, and acid dyestuffs and the salts of starch, gelatin, clay and charcoal, they form negatively charged colloidal salts. Electrical double layer theory explains the origin of charge on the colloidal particles. When one type of ions on the electrolyte are adsorbed on the surface of the colloidal particles, it forms a fixed layer. It attracts the counter ions from the medium, forming a second layer which is mobile and is called diffuse layer. And the double layer, that is fixed layer, and diffuse layer of oppositely charged is called electrical double layer. And the potential difference between the fixed layer and the diffuse layer of colloidal solution having opposite charge is called Zeta potential. So, Zeta potential is a scientific term for electrokinetic potential in colloidal solution. Zeta potential is also called as electrokinetic potential. Now let's discuss the another property, that is electrophoresis. The existence of electrical charge can be shown by the process of electrophoresis, and it involves the movement of colloidal particles towards one or the other electrode when placed under the influence of electric field. And the movement of colloidal particles under the influence of an electric field is called electrophoresis or cataphoresis. And in this, as soon as the particles reaches the oppositely charged electrode, they get neutralized and hence they get precipitated out or coagulated. Now let's move to the another property, that is coagulation or precipitation. And the process of conversion of colloidal particle into precipitate by adding an electrolyte having opposite ion is called coagulation. And the opposite ion which is responsible for coagulation is called coagulating ion. And the quantity of electrolyte which is required to coagulate a definite amount of a colloidal solution depends upon the valency of a coagulating ion. This observation of Hardy and Sluice is known as Hardy-Sluice law, and it states that the effective ions of the electrolyte in bringing about coagulation are those which carry charge opposite to that of colloidal particles. These ions are called coagulating ions, and greater is the valency of the coagulating ion, greater is its power to bring about coagulation. Now let's discuss some other methods which can cause a coagulation, and first one is electrophoresis. In electrophoresis, the particles of dispersed phase move towards oppositely charged electrode and get neutralized. If the process is continued for the sufficient time, these neutral particles unite and grow in size and settle down. So, this results in the coagulation of colloidal solution. And next method is by mutual precipitation or by mixing two oppositely sols. When two sols carrying opposite charges are mixed together in a suitable proportions, the colloidal particles of one sol neutralize the charge present on the particles of other sols and both get coagulated. And next one is by persistent dialysis. And we studied that a small amount of electrolyte is essential to make a sol stable. But when a sol is subjected to the persistent dialysis or prolonged dialysis, the traces of electrolyte also pass out through the membrane. And in the absence of electrolyte, sol becomes unstable and gets coagulated. Thank you students, and have a nice day.